So we are also now going to look at PV system installation, how we do the testing, and how we do the commissioning. Actually, the commissioning, I will handle it on Friday. So it's not much here that talks about the commissioning. I'm going to mainly show you how these panels can be fixed on the roof, what kind of work you need, what you need to do. I wish I had more time. I would have gathered more of what you need to see, but we can still see a couple of days. So you did the planning, but now we are also going to do the planning on when you are going to do the installation. And then what are the tools you'll be needing to do the installation, and what materials you need. How do you do the system check? How do you do the inspection? How do you do the final testing? What are the safety measures you've taken care of? And are you going to just dump the system to the user without saying anything to the user? As a good practice, you should try to make sure that you help the user to enjoy their system. Don't be mean. Tell the user everything, and I will give you one trick. The more you tell something more things, the more they don't care about understanding, because the rules come to you. That's the trick I use. If you are mean and someone asks you, says, you go look for it, they motivate you to go and look for it. If you tell them everything, they will go comfortably. Then when something goes out, hey, how are you? How do we do this? Then you become the resourceful again. So the more generous you are, the better. And already now you have knowledge about transiting from a small solar cell to when you arrange them in one module, and then you can have a bunch of modules put together. You can have all these many modules also made into another. So that's the transiting. You transit from one solar cell, which we saw on the other panel we had, and then when you arrange all of them in a line, remember the line which I was showing you, remember to make in where we put a bus that goes to the next one here. So you are building with this kind of panel, and then you can have a bunch of these also made to be a group. So you don't need to be limited by how they look like. You can have a bunch of them and have what we call a solar farm. So what are the objectives of this session? At the end of this session, you should be able to plan an installation. You should be able to identify the tools and the materials that you need. You should be able to do a system checkup. You should be able to look at the system and immediately say something is wrong here. A good technician is able to look at even your system and say, I can see a lot of dust. Probably by blowing fast, I may solve the problem. And then how to be able to do final testing of the system and commissioning, and be aware of safety precautions while installing, and do the best or conduct best user training. Every time you go for an installation, you can even do a small, like one page of instructions to the user. And do it as, put the advertisement. You have done one page, you have put your points there, you put your logo there, you put your PO box. It's a free advertisement. But most Ugandans, or even Africans, because of doing shoulder work, they can't put the address on what they have done. But for you, I guess that would be the best advertisement. If you can do an installation and leave a leaflet, brochure, and tell them you do A, B, C, D, E, F, G, and then actually if you go to my channel, you find someone doing windscreen repair, and although he doesn't talk in the video because I removed the sound, eventually he tells the customer on how to care for the windscreen after repairing it. You too, you can do another at the end. So it's all about the energy source, which is the sun, the conversion by the panel, the inversion and conditioning which we have already done by either charge controller and or an inverter, and storage by a battery, and then load by either using the bulb, either distributing it or even going to the extent of putting it to the grid and selling it to the grid. In most homes in the United States, they have panels on their rooftops, almost the whole of the rooftop covered. And during the day, they are at work. Then they can generate all that sunlight from the sunlight and feed to the grid. And then in the night when they come, they use the grid because the light is no longer there. So most of them are not even having any buffer bar because in the US, power doesn't just go. But also the government encourages them to generate because, for example, if our houses in, for example, Dinda, we are going to be producing electricity during the day, which goes to Burma Road, okay? For photocopying, for printing, for repair, for all that. And I'm here at campus doing the work. My house will be generated. So they have what they call two-way meters. A meter that shows how much you are generating and a meter that shows how much you are consuming. So you find some guys actually not paying for any electricity because what they generate is almost equivalent to what they use. And then the balance is almost zero. And so this is to do with the grid or mini-grid type systems. So the step one in planning our installation, our first step, you visit the client and do a load assessment of the energy requirements. You do not sit in your place and say, okay, I will come and install for you. You can, that's why this question of how long is it going to be in terms of the wire, how long can you go? So you go to the survey, to survey the location, the site. And then you look at how far away he wants to put all this stuff is. And then if the energy requirement needs bigger system, you say to the client, if the client is saying, I want a battery of 50 ampere hour, and then he has a huge TV of 100 watts, you advise the client and say, please, a battery of about, because if you talk of a battery of 145, for example, I mean like a lead acid, the equivalent of this lead acid car battery, or 45 ampere hour, and then you want to put a TV of 100 watts. If you look at 100 watts compared to 120 volts for a home supply, and then you look at the current, you can imagine if you were to draw 1 ampere from your system, if it is a 45 ampere hour, it means that you cannot be good for how many hours? If you are drawing 1 amp from a battery of 45 ampere hour, how much time will you spend if you are only drawing 1 ampere? As you are calculating, I will continue. So you inform the client particularly of income generating activities from the system if any. If this is a village person who is installing it at the home place, you can tell him, by the way, do not despair. You can always tell your neighbors to come and charge their phones here. You can tell him you can buy a small computer printer and print for people here, or even buy a small photocopier, these printer inkjet photocopiers, or scan them, and then you scan for people when you have charged your battery. Because the more you bring your battery and charge it, the better. So you can also put an idea of income generating activities. You don't just tell somebody have a system home which just sits there idle. The other step is that after having done the design of the system, which you were doing by knowing you've known that he has a fridge, you've known he has a radio, you've known he has lamps, you've known he has a TV, and then you have done a design and you know how many modules he needs, how many batteries that are there, how many lights, to mention but a few. If the system is more expensive than what the client can pay for, and he chooses a system with lower power output, make sure that you tell him the implications. You tell him you're going to use that huge TV, but you are going to watch it for only 1 hour. And your battery will be low. So if you want, you wait for a and don't watch that, and it shuts down, and then you go to sleep. but at least you would have told him of the implication. The other step is to explain the expected lifespan of the system, which is on average about 15 years. That is in ideal conditions. But on the conditions where Carol comes and sits on the panel, where the dust from our roads, from our gardens is collecting on it, where the sun is shining like hell, where all the windy accompaniments are blown to your panel and hitting it, or hailstorms, it may be different. And explain what it means to maintain the system in the long term. The battery maintenance and replacement in about 2 to 5 years, depending on the maintenance and the depth of the discharge. And then the lifespan, roads like lights. Of course, lights also depend on their own lifespan. Mr. Kaumba will be able to show you in the subsequent times about the energy saving lamps. They actually have a circuit inside for stepping down the current. You have resistors, you have transistors, you have transformers within just that small lamp. So you'll be able to show you the circuit inside there. So when you are putting these lamps on the system, you should be aware of how long they will last. The other step 4 is where do you locate the battery? The battery you have to discuss with the client the most suitable place. You know, the client has a living room, has a store, has a kitchen, has a bedroom, has a guest room, kids room, etc. So you'd have to understand where this should be put. But in that kind of discussion, make sure that you tell the person that it should be a well-ventilated place, in addition to being a convenient place where you can easily go and switch on, switch off. It should be away from children, so it shouldn't be located in the children's bedroom. It should be well protected. It shouldn't be having dust collecting on it, things falling on it, and should not be near highly used areas where people may be even tempted. Imagine it is in the kitchen, and your house girl just gets a saucepan or medium and puts it on the battery and then shorts the two cabinets. So it shouldn't be in a place which is too high dependent. The other step should be that it should be off the ground. The module location should be off the ground. Why? Why should your module be off the ground? We already talked about it here. The dust. It is easily covered by dust if it is on the ground. When there is much rain, the splash will cover it. Even animals and insects like rats will easily climb on it. Some fun animals like cats will even want to rest there because it is always looking nice and shiny. It should be not near kitchen or chimney. Of course, why? Because kitchen has a lot of heat, and we already talked about ventilation. It should be not too hot. If tin roof, 20 centimeters above, you shouldn't make it on the if there are iron sheets, you don't make it sit on the roof. Give it about a couple of centimeters to make sure that the cool breeze helps you to cool it down a little bit. Tomorrow when you go out for more experiment, for more practicals, you will be able to realize if you short, do not do it. If you short the two terminals of the panel and you hold on the surface, you feel it is heating up. But don't do that because you may spoil our panels. It should be located where it gets more sun all the day, so you shouldn't put it under the tree. Why? Because when you are characterizing the day when you are doing characterization of solar cell, you were able to see that shading off one cell blocks, like cuts off the chain. Remember when I was using the chain of relaying the blocks? And it should be as close to the battery and controller as possible. Why? We talked of if you make your panel to be on the other side of the elements, and then you put your battery here, you lose that energy across. So you shouldn't have the battery and the controller being far away from the module. The word module, we are using the word module for the case of the panels. And it should be in a secure place where there is a minimum chance of Africanism, of theft and vandalism. And I'm sorry, that's it. You either have to, all of you, repent, but when they see an African, even when they see an African American, immediately they think he's going to steal something. They call police. And you know, a few months ago, there were a lot of, I call them protests in the United States, protesting the killing of a couple of young people. So the theft and vandalism should be a case, and that's where we are going to play an important role in terms of how to protect these things. So whatever I've talked about so far is that you can mount these panels on the roof. This is a metal sheet roof mounting system, which should be having a spacing, or it could be on the tiles. This is also another mounting on the tiles. It could be the windscreen mounting system, where you just put your rack and then put the things there, or you could be having a flat roof. Like on our rooftop there, it's almost flat. Or you've seen buildings where the top is just concrete, and that's where it ended. So you can construct these kind of blocks where you fix them and then put an inclination to make sure that your panels are well accessed. And an example of a real house, house roof mounting, and these are your modules. This is like an example of the panel we have here, I think. And then you have a bunch of them aligned together to cover the whole roof. And they are mounted using different tools. So, how do we mount the module? We prepare the mount, because you don't fix it from the top. If you are going to put on the roof, you first fix them on the rack which you want to use, and then go on the roof, fix the bolts which you want to use to fix it, and then after that you carry your panel reach there, arrange it properly in the bolts, and then tighten the nuts. You're done. And then it can be fixed or tracking. The mount can be fixed like on the roof, tight there, or it can be tracking, whereby it can move and turn depending on where the sun is. And that's a simple logic. You put a sensor, a light sensor, which is coordinates with the motor, but then you see you use some of the energy you're producing to move your mount. And it should be weatherproof. So you shouldn't have something like clay which soaks and breaks into pieces. And also which withers with time. It shouldn't be corrosive. That is, should be corrosion resistant, like aluminum or steel coated with an oxide. Wood with suitable varnish can also be able to work. And then we have all nuts and washers, also weatherproof. And this is what I've been talking about almost, that you get your mounting place where you want to mount your PV system or panel. You put the roof anchor, you put a mounting frame, you put the clamps, and this is, for example, how you get this one and fix it on your roof, and then leave this other bolt where your your panel will sit. Some of them look like this. They are range of these boards. Some can be made manually or can be made, both when they are already made. This is a glass composite. I'm sorry about that. This is a glass composition mount where you have to fix your pan around these points, and then it is able to be fixed. And please, as I said, when you go to the internet, you get all these, and you can even go to YouTube and type in how to make my own mounting rack. And some guy, just like the one who was making the panel, will just give you a video on how you cut them, how you drill them, and how you make all of these. This is, for example, one where it goes through the roof. You have seen it here. So it goes through this other, like the wood part of the roof, and get fixed there, so that you deal with the part where you will be able to fix your panel. And a quick, fast pitched roof mounting system. You have the anti-rail, you have the splice, G-module, end clamp, interclamp, corrugated screw, the hex-head board, roof hook, etc. All these can be fabricated depending on how. That's why I told you that this is business. If you can get your machine, you go to your machine which makes bolts, you just make your bolts, you make your clamps, and when people come for buying the panels, you say, and here we have a set for your racks, and you want to make the price, because you might find that you are the only one. Instead of this, you go to weld and protecting. And you can make them special. You've seen these Chinese products or South African products, where the bolt, the screw where you put the screw is already bent like an X, not a star, but like an X, which is really hard to get a screwdriver. So you even buy a toolbox from them, in addition to buying the materials you are going to be using. And so we have fixed mounts which can be on the roof or a pole or ground. Fixed mounts should be flat and well ventilated, strong to weather conditions. You have already seen that. For rooftops, use racks or brackets. They are safe, but it's hard to clean this kind of modules on the roof. Consider pivot to change angle at time due to season change. I already showed you the wobbling of the earth. So I already told you that on the other side, sometimes please don't play with the switches. They are meant to be switched on once. So when the sun is moving, that slight displacement, you should leave your rack to have some pivot where you can increase the angle or reduce the angle. Because remember, we said we are going to put our panel to face in the east-west direction. But again, as you would wish to have enough sunlight if it was to be normal, so that there is no reflection taking place. Otherwise, when you do like this and it is bouncing off, you may not get enough. So the actual tracker should be tracking the sun so that the incident sunlight is always, the photons are always hitting at 90 degrees. So if there is a tilt in the sun, then that angle will adjust, the zenith angle will adjust a bit. So you should leave your installation having some pivot to change that angle, and that's what it means by this other statement. The pole mounts are best for up to 4 modules. It's expensive. It needs metal pipes which are huge, and maybe the foundation. You need some cement somewhere, some concrete. So if you have one pole and you are putting these panels, they are a bit heavy. So you need a big pipe. And ground mounts best for 4 or more modules, can be fenced off for security so that no one just comes and picks them when they are on the ground. For roof mounts, use ladders and work on boards to protect roof damage due to weight and have minimum people on the roof. Don't take the whole group of people on the roof and they are stepping anywhere. If we manage to get a chance, I can make you just people on our roof. There are instruments there, so because many people go there and they are not aware, some of them walk in the middle of the, you know, where the nails are, that's where the beam is. Okay? The wooden beam or the pole, whatever you call it. And you find someone now walking in between the nails and the things are bent. The iron sheets are bent. So make sure that there are fewer people. Use ladders which are firm. Avoid tearing off the roof. Don't try to start removing the roof and say, let me now fix the thing well here. Once a nail is disturbed, it never fits like it was fitting before. That's why you get leakages in some of these places. And you find like a whole mark. Actually, in the other room, it is easily seen. You find a whole mark somewhere because the water is leaking on a different spot. So this is an example of a pole mounting, and you can see you need a foundation where this pole will be. So if you have these are 9 modules, when you have such 9 modules, you really need a strong pole. And that's what I meant by having a better, or the expenses in having this kind of pole. Otherwise, you would prefer to put them off the ground a little bit, and make sure that they are easy to turn, and give them some pivot if you were to turn them. And this is an example of an already done. This is to show you the inside of it. And as you can see, there is a chance of a tilt, whereby you can do some tilting around this other place. And down here you can leave it as a farm for some sheep, goats, or whatever can go around in your system. For array, first fix modules to the frame or ground, then attach to the fixtures on the roof. Use the method of mounting, use compass or inclinometer, and should be a bit tilted to about 5 degrees. Now, the compass is to show you where the north is, where the south is, where the west is, and where the east is. That's why you need a compass. Also, an inclinometer is to show you the angle that you are at that place. And the tilt, I don't need to answer this question. We've already talked about why you need to tilt it. The step 6, where do you locate your charge controller? Because look, we are looking at the panel, because we are looking at the whole PV system. So we are looking at the panel, which is we call it a module. We control the charge that is coming out of it. We take the charge to the battery for charging. After the battery, we either take to the inverter for the consumption of AC components, or just drain it directly to our DC load. So as close to the battery, the charge controller should be as close to the battery and modules as possible, but not directly above the battery. It should be close, but not just on top of, you don't put it on the terminals. That's what it means. It should be mounted on the board, then to the wall. Don't fix it on the wall. Fix it on the board, and let the board be the one to be fixed on the wall. And now the following manufacturer directions. Read the instructions. I can bet none of you read the manual of your telephone number, telephones. Any one of you who read through the manual of your mobile phone? You just bought, actually you could have left the box at the shop. And not in the carrying your charger here, put your, if you were having the phone with earbuds, you just plugged them in, went home shaking your head, then dumped the charger there. Please, from today onwards, read the manual. The manual is always over 10 pages. Why do you think the manufacturer who needs to make more money and more profit would make a manual of that much and for these many products. If you read your phone manual, you realize that there are a lot of functions on your phone that you have never used. And when you read through is when you find that you have been hustling to use your phone when you couldn't, or when you didn't need to hustle with your phone. And safe but easy to access. Put it in a place which is safe, but don't put it underground and hide it in the ceiling and say, I want it to be safe. Let it be safe as well as accessible. And then the other step is where we locate our switches and our lights. This is a discussion you can have with the client for the best position. So for your case, if the person wants the light in the farm, on the other corner of the farm, you discuss. Step 8, you prepare a wiring diagram for the system. And they mark this point clearly because tomorrow you'll be using it. You have to make a wiring diagram so that you can even leave it for the customer, so that they can be able to track. You may die tomorrow, or you may be transferred to far away countries, or you may go away, or you may decide to retire from these things. So someone should be able to track your wiring system. And that's why innovations have kept on coming. Otherwise, if people who did things just did them for themselves, we wouldn't be carrying on. So do a wiring diagram so that you are able to follow it. And tomorrow, you'll find that without a wiring diagram, you can't do much. Continuing the way you draw your wiring diagram, you ensure that nothing is overlooked. Don't say, well, anyone will know that there is a switch here. Then you jump in. Don't underestimate anything. You should also know about cable sizing, which should be done rightly. Nothing should be forgotten. Ensure that useful documentation for the maintaining of the system is provided. And tomorrow, Friday, in the PV maintenance presentation, I'll be able to show you what kind of documentation you need to be able to provide to the customer. How we still planning our installation, make necessary calculations on the voltage drops and losses, and envisage the losses that will come up. Because if you know that this much length is having this much resistance, then you are able to know the I squared R, which is the dispersion. And then if you have added these many feet, these many meters, then you will be able to say yes. Now the losses will be. So you tell your customer, you who was talking about the farm, you tell the customer, if you go up to the other corner of the house, your light will consume this plus this loss. If you continue to the other corner of the kitchen, this loss will be available. So choose where you can put your light and have appropriate drops and losses. You get the necessary legal documents, if any. If you can also be enterprising and say PV system law and tell the person the kind of things that are involved with PV system. Because if somebody was passing by, or if a bird, someone's doves came and landed on a PV system and got electrocuted and died, someone will sue you and say your PV system killed my domesticated birds. So I want you to pay. If any necessary legal documents, then you can also enlighten the customer. So you need a couple of tools to do all this. You don't just come and look at the thing and say, let this be, and then it is done, just like how God created the world. So you need modules, you need the racks. I will use the rack to need the frame, so you need the module mounting structure, and this should be hardware to connect to either roof, the core, or the concrete, or whichever other method you are going to use. Depending on the type of the mounting, you need the cables, you need the electrical conduits, because these are pipes sort of where they pass through instead of leaving them naked. You may want to pass through the pipe. This is a conduit here, because you don't see any wires coming down here. So this is the conduit. This is what we mean by a conduit. You need a controller, you need a couple of other hardware, you need fuses, circuit breakers, barrier box if you need it, timber for barrier where to sit, fasteners, lights, switches to mention by the few. And then you have the installation tools, you carry a toolbox, you carry a hygrometer to measure the state of your barrel, if it is lead acid, and then you were introduced to the multimeters the other day. So you need a multimeter to know the voltage, that is the short circuit current and the open circuit voltage. And as you do the tools and the like, this is another way of mounting, just like you see, say like dishes being mounted. This is the way some of the clips hold your panel on the roof, and this kind of rail, you can either push it upwards or push it downwards and then tighten. It's the same thing here, you can move this rack towards the other side or this side, and this is how it looks like. You can see a nice bolt in here. This is the corrugated rooftop, which we are all used to. So it's your ingenuity that sometimes you may not need even to go to the retail shop or whatever. You can still do it and produce these things. And then you'll be the only expert in town who can do all this stuff. And this is what we talked about, that you can make the whole of these racks at the beginning and then just carry them to the roof. This one I've already talked about it, but just to make sure that you get a visual feeling of how this whole thing looks like. And you can see another alignment. You first put all these mounting supports on the top of the roof or on the ground, depending on where it is appropriate, but this should be a roof. If you compare this pole here and these other trees, because almost this tree is disappearing. And then after you have arranged them nicely, then you come start putting your modules on top of these supports for mountings. And this is another rooftop. This is a gutter, this is the wall, and you have your panels all arranged there. And just to give you an impression of how all this is done, you have this kind of mid clamps in the middle here. And as you can see, it has a gap here where this panel fits, and another part here in which a panel goes in. So that's why we call it mid clamp. It is in the middle of these panels. And then at the end here, if you can see, at the end you have this L fit, which you put, and then here you have a rail here. So the L goes into the rail and fixes it so it does not slide out here. And then you also have to make sure that it doesn't slide off this other side here, and you put an end clamp to fix it there. So now you know how you can fix, and you can see, although it is not so, it's too bright, but you can see that this was a corrugated iron sheet, if you look here. So this is how we fix our module on the rooftop. And just to give you a feeling of how it would look like, because this other one was to show you the kind of clamps that are on each of these, but this one now shows you how your module is sitting there. These mid clamps are here, and the rail is here. This was the rail, and then the end clamps were here, and the L clamps, which were avoiding it from sliding down. And more depending on anyone's roof, depending on anyone's mounting location, you have these other, parts put, and then you can come and fix your panel on these other places. After you have raised all this one is to raise it from the rooftop. And this is how a universal tile fix will do. This is a tile, this is a tile, and then you fix this other one here, and then you are able to have where to put your panel at the top. And these are other screws, another type of screw with such kind of tiles. We've seen these houses with tiles which are not these semi-ceramic or whatever, which are just flat, which keep just being put on the top of the other. So after all the items are installed, you connect as follows, and in order for PV systems, you have to have fuses. So you have to put a fuse between the battery and the controller. So between your controller and the battery, you need a fuse there. So that the charge, the charge controller controls the amount of charge, but in case anything happens, then make sure that you are able to have a fuse in between. You also put a fuse between your module, that is on the module line. You put a fuse in each of the load circuit. Each of the load you are going to put, you have to put a fuse there, which is in consonant with the load's amount of energy it is going to use, the current. So that if any current comes greater than the current the load is supposed to use, you only lose a fuse, which is easy to replace than losing your radio, than losing your lamp. For systems with no fuses in each circuit, connect a battery and charge controller, and then you connect the load to the controller. Also, all loads should be off. You connect the module to the controller, so you should, at least the charge controller controls the amount of charge coming out. So in case you don't have the fuses, you make sure that the charge controller is helping you in that respect. That is not really a big concern for now. So while disconnecting the system, remember we are installing, we are checking, we are testing, and we shall commission. So while disconnecting the system, for fuse circuits, you have to first make sure everything is off. You switch off everything, you remove the fuses to the rods, you remove the fuse to the solar modules, you remove the fuse between the battery and the controller. Where there are no fuses, you just remove the fuse between the battery and the controller. You remove the fuse between the solar module for the controller, because the controller has its own fuse system, but you will see that when we go out tomorrow. Still under connecting our system, if you have we've already talked about this, while disconnecting the system, I think I'm repeating myself. So while in the guidelines, we are connecting the PV system, we've already said in planning, you plan by designing the circuit diagram. So use your circuit diagram. You keep a copy of the diagram near the control box. Follow established table in color codes. Electrical wiring codes for either East Africa or British color coding system. You make sure there is a code for direct current, where black is always negative, red is for positive, sometimes brown line, which we call hot line, or we call it live. For when you are looking at the alternating current, blue is always for neutral, yellow with green stripes is the earthing, and orange earth module frames and loads. So when you are connecting your PV system, make sure that you have an earthing from the frames of your panel and your loads. So how do we do some checking and inspection? After electrical connection and loads are off, we check the connections again, see whether everything, the nut you are supposed to put, the other part of the connection, look at the charge controller, whether the wires are all well put. Make sure that they are firm and properly connected as per the wiring diagram. Be keen to not loose ends. Try to touch and see. Test the current continuity in all connections. You remember when you were using a multimeter where it was doing when you put it on the part of the diode part, and that pattern. When you put them together, they make noise. You can use it to test the conduit of the system and test for system voltage. If you are satisfied, you turn on all the rods and then observe for some time and see whether the lights are going on nicely, whether there is a radio is playing without having any problems. Other issues to consider are aspects of safety. You should have maintenance. On Friday I will show you that you need to have this, how do they call it, Mike? This thing you tie around so that you don't fall off, forget the name.
Yes, works.
No, there is a nice, you've seen climbers, mountain climbers, who have a hook they put and then it is tied in their waist. You should have that. We shall see the name when we are doing this on Friday. You should dress it when you are doing the installation, but also play safe when you are up there installing. So supporting structures, e.g. ladders, sloping roofs, carry out measurements with modules and arrays, undertake operational testing of the inverter and the generator, carry out basic roofing techniques, field test of PV system components to check the conformity of your components. So you try to test the open voltage and the short circuit current before you even bother to put your system at use. You need to remember that the system must be safe wherever you are putting it. Wiring must not degrade the system performance. You don't put these long wires which are very tiny and then the losses are too mega that they take almost everything. And you should make sure that the components must perform optimally. Remember, a PV system installed without an inverter is low voltage direct current system. If you have no inverter, it means you are just using a few DC appliances. And wires for installation are not like for the AC installation. This is one mistake some people make. You should get wires which are not like these other one strand wire for the AC which we use in most of these wirings around. I don't see any of these, but in the lecture theater there are those wires. Even I think in the second year when we are trying to make a connection. In any installation, think safety always. Always have a well-trained partner to interact with. Don't take a porter whom you say, give me that pliers, and he says, what is that? And then you say, give me star. He says, there are no stars in the sky. So you should get somebody who is well-trained, who will make your life a bit comfortable. So with the safety tips, modules are expensive and they are potentially breakable. If Mike showed you a few of the panels, of the solar cells, you must have seen how fragile they are. And that fragileness is not only just on the cell, even the whole panel, the whole form of it is a glass. So they are breakable. You must make sure you transport them with care. Don't put them on a border and then you are going to a village place, you are banging into holes, you reach the installation place, it has wrapped, and then you say, I don't know. Beware of shocks when wiring. If you are having a big system, if you were to produce how many voltage, what was your open voltage for the one you had? What was the open voltage for the panels you had outside there? You can copy from your exercise, which you did. What was the open voltage of the panel? Okay, 30. You said 30, 20, 30.
39.5.
39.5. So you can imagine if you have like 10 of them, it means you have multiplied 39 by 10. That's the amount of voltage that is available. 390. Almost close to 400 volts streaming across your PV. So shocking you is easy. That's why you make sure that you are aware of the shocks. And DC is a bit dangerous when it is high level. Although the SE makes you shock, DC gives you a good kick, and which is direct. It doesn't play around with you. The SE may shock you and you fall off or you get thrown away, but the DC will just pull you and say, come and give you a nice roll. Disconnect or cover the area with a blanket when wiring to avoid shocks. So like if you are trying to wire put something insulating, or you can put on these gloves. Mounts well on the roofs. If you were to be putting these modules on the roofs, use stable ladders and position them correctly. Don't put the ladder on the wall at 90 degrees. And then you drive in the middle, you get some good swaying around. So have somebody to hold the bottom part of the ladder. And this somebody also should be understanding. You don't get somebody who puts the leg like this and says, hello, okay, now. And then leaves you alone. That person should be taken for and use ladders or planks while walking on the roof. So you shouldn't just walk on the roof and start spraying the roof. The other safety tips on the batteries. Batteries need to be handled with special care. I'll show you this in the maintenance presentation. Wear protective clothing and glasses. Use a funnel to avoid splashing when filling the cells. Always keep fresh water available to rinse your spilled acid clothes. I will record this on Friday. Keep baking powder close to neutralize the acid spilled on clothes and other floor. On the floor, or even when it spills on you, baking soda or baking powder, they say it helps in neutralizing the acid. You can revisit the chemistry. And take care of the current from the solar area. What was your open circuit current? Short circuit current. And you can imagine 2.5 amps are too big. It's not a small current. And so also the current from the batteries is always too huge. Always after the system, run the wire from the negative to the earth, so you can use the negative as ground, and also connect this from the negative of the battery. When you look at the car systems, the car system, the negative of it is connected to the body for grounding. Although the tires will not allow the car to be on the ground, but the whole body of the car is assumed to be a grounding of the sort. So all other parts need to be grounded too. The frame to mention, but a few. So cables. Don't just put your cables fakely. Lay your cables neatly. Use a wire stripper to expose cables. Don't start fidgeting with your cables. You may lose your tooth, or you may get a complexion or a complication of within your dental formula. And be careful not the cable to be long or short, or not to damage the X section or the cross section area of the wire. You are planning your system, and then you start chopping the cables at will, and then when you start connecting them, the junction box is here, your cable ends here. And then you start casting, and you cannot go back again and buy more one. So you make sure that all that is done cleanly, and as a safety precaution, please, the moment you're going to be working with installation or checking or whatever, first switch off. Don't start shaking the wires to see whether they are firm when actually the bulb is on and it is now being interfered doing all this part. People are finding They call me when I'm busy. When I'm in the office, I don't get any call. Okay, so wires from the modules should be sealed off. Make sure this wire enters where it should be going. Also, when it comes from the module, seal it off so that the rain does not, the water soaking does not. Sometimes it may rain so much that it is wet all along, and then if they are naked, you have a connection between them because of the water. And then, if you look at the safety tips with the charge controller, handle with care. The dangers are that they are banned from the heat of tools and conducting objects when in contact with the battery, and terminals of the connectors can arise. Sparks can be ejected and ignite combustible materials. You may be having something combustible around, and the spark can cause anything that you did not expect. And you can give a shock from charging equipment or batteries. Wear protective gear. So it's advisable that you should have goggles when you are working with all this stuff. You should have strong shoes. That's why technicians always put on jumbo boots or gum boots for that matter. You should have a head cover. You should have gloves. I've already talked about the goggles. And when dealing with batteries, these are very crucial. The gloves should be rubber so that even if the acid spills, it does not burn you. And even if it burns the glove, by the time it burns into your skin, you have removed it and reached the clean water or reached the baking water. Exercise a great amount of caution all the time. Don't be careless when you are dealing with these installations. And remove charging current when working with batteries. Remove any metallic conducting materials in your body, because working with the batteries, when you are working with batteries or you are doing installation, don't put on, you are having the chain. I don't like having metallic things on my body in a good traditionalist. So you are having your rosary, which is metallic, and then you are trying to flip the other side. So one side of the rosary has gone to the negative, and as you go to fix the other side, it has touched the positive, and then you become a living spark. So ensure tools are also insulated. You've seen, that's the reason why you find pliers, magalos, always having covers on their parts where you store them. When all this is done, when you have been careful, whatever you have done may be useless. Just like if you are a teacher and you teach kids and you have labored, and after laboring, they go home and throw away the books. Exams, your neighbor comes and they scratch their heads. When they all get zero, who is to blame? They will blame you. Maybe, unless if you are like me who carries a camera who can say, see what I told. But if you don't carry the camera, you have any evidence, or you don't have any relative in that class to attest that actually you told, then they will, and kids can manage to do that to you, thinking they are punishing you, but when they are just spoiling their future. So you must make sure that you have some small user training, and make sure you train your customer or client on the best maintenance. And this best maintenance includes regularly wiping the modules almost every 3 months, depending on the location. A location which is away from the roadside wouldn't need regular cleaning like the one on the Maram Road side, like Natet. If you were to have some panel near Natet where the road is had just been it has just been graded, it is dusty, it's different from if you were having a panel like around here in Mackay. And also would be different, if we had a panel here, would be different from if it was like at the Freedom Square where there is no dust. And so we already said that use clean water, and also make sure you use a soft cloth. Do not use soap, because detergent reacts with the glass. it creates these yellowish things, some colored things, and then makes the glass look different and reduce on the efficiency. You regularly clean the batteries at least once a month with clean water and cloth. Don't pour water on the battery. We mean you put clean water on in a piece of cloth and then wipe this clean cloth on the batteries. I will show you more in the maintenance presentation. So, how to check the battery, the acid level every about 2 weeks. How to clean the terminals with safety precaution. How to take the battery from normal charging. For normal charging every 4 months. Remember, just like you saw the weather in the morning, sometimes you may not get enough sunlight to keep your battery moving, as in to collect enough and charge it. Just like our tank, if you remember, in case you had not come, I said that you have to compare, or you had come, you have to compare your PV system like the water harvesting system. So the rooftop of an iron sheet or whatever else you have as roofing, that collecting of rainwater will be the same as the way you put a panel to collect the sunlight. And then you have to transport it towards your tank. Now if you had your tank at Freedom Square, how would you transport the water up to Freedom Square? Even a drop every other part meter of the gutter. By the time your water goes to Freedom Square, you have lost almost like 3 acres. Comparatively to the wires that we are talking about, that's the same analogy. So then you need to have a tank where this is kept. And in the same respect, you must make sure that because your battery will not charge, if it doesn't rain, you don't have water in your tank. So you go to the tap or you go to the well. And maybe if you have a vapor, you can pour the vapor and then they refill you up. Similarly with the battery, because of weather, some of the seasons, like rain season, you won't have enough to charge up your battery, but you still need to watch your TV regularly without any chance of, you cannot say today I'm going to take a break on watching the battery conflict. So you have to watch it. But then if it was not shining that day, then your battery will be drained almost beyond what we call. So you take it to give it hard charge. And I will talk about that again tomorrow, Friday. So you have to train your person that after all this time, like in this season, take the battery to the charging people so that they give it a thorough charge. So battery not connected, charge every 6 months. If it is not connected, like you have not used it for some time. Replace battery after the end of life, 1 to 5 years. If you are going to install solar panels in geographical areas where soiling from last sun or grit will likely be a problem, consider purchasing panels with low affinity for soil retention. Get some panels which are well nicely made, smooth, with an outline on the other side also neatly put and covered, so that whenever the dust collects, it just slides off. And if it rains, it cleans it off.
Excuse me.
Yes, please.
When you look at that, I think we are going to concentrate more on panel batteries and acid batteries.
Sure. I wanted to say that, but you see, true, but what if the customer has the acid batteries? And if I don't know whether we shall get a chance to go to Greek or whether the people from incubation section have visited Greek. They still use acid batteries, huge ones. They are still very versatile, they are still very useful. But when you can't look at it in terms of the car batteries we talk about, which are, because I think an average car battery, which is not for a tractor or a fuso or a semi-trailer, is about 45 ampere hour. it's useless to a home user who may want to use his TV. So much as we may concentrate, why not? You may need to charge your phone or just play music, because with music the lead acid still works fine if you are going to use play your home theater. Yes, please.
Yes, there are some solar batteries which, there are deep cycle batteries designed for solar. Like now battery, Uganda batteries limited and Exide, Kenya manufacturing them. They don't necessarily have to be sealed. There are deep cycle batteries which are dead acid by deep cycle.
Yes.
The difference is just the design. For a car battery, it has like very either thin or thick plates. So it's designed for withdrawing current, a lot of current in a short time. When you're starting a car for the starter to go in, it draws a lot of current. But the deep cycle batteries are designed that in a way where the form where you can withdraw just a bit, or like 10 amps or 20 amps, but for a longer time.
Thank you. So now we know why we're still talking about the acid business. Okay, so then we have so still in our user training, you always need to check the mechanical construction of each panel before you install it. You need to know how it looks like, and as you are training the user, also the user must know how it looks like. You verify the glass, if the glass is iron and the aluminum frame is robust. The solar cells inside the panel can last for about 20 years, but they are fragile and the panel must protect them from mechanical hazards. So you tell the user, as you train the person, these kind of things, so that they do not put things on the panel thinking that they are supporting it, when actually it is spoiling the kind of panel. All in all, you now know how to mount one. You did mounting and configuration the other day. Now we have done the installation and we have done the testing. We've done almost the commissioning. But I'll do the part of commissioning more on Friday, because I'll do a bit of commissioning and then give the maintenance. Because even when you maintain, you still have to commission. Whenever you are, like, just like when you take your car for service, they will do the service, and after service, the guy will come with the paper to show you what he has added, what he hasn't added, what he hasn't touched. That's similar to commissioning. So every time you are called to maintain a system, you reach there, you do all these things, you check, you diagnose, you get the problem where it is, you fix it. After fixing the problem, you again give them fact sheets and other documentations, which I will show you on Friday. And for that matter, I would like to end here and thank you for listening and invite any queries if there are any. Yes, please.
Anyway, to add to what you just say, that thing like acid battery nowadays is still existing in the world. Like this big government programs. Some of them are trying to say they like solar for acid batteries, because most of them like there's one we installed somewhere is 200 amp power. But the only thing we told them was just to check on it, make sure the place is not connected with anything and the feeling is still working. That was seen just I think after now, the thing is still working well. And for a question, we are looking for connecting the fuse between the battery and the controller. But the other one has actually indoor fuse. I don't know if that one, it is now for almost all the system. Because when there's a problem in one jack, it blows. When there's a problem in the battery, it blows. When there's a problem in the array, it blows. I don't know if that indoor fuse is cut us for all the system getting out from the
You see, like when you put a controller, charge controller, you are having your module going into the controller, and then you are having your battery going in. One lead to the battery, another leads to some of the appliances. And if you want to put the light in straight. So the fuse is basically for the fuse in the controller is basically for its protection. That the charge which is from the panel wouldn't spoil. But also you need to have, if your battery is a given rating, you need to make sure that what goes to the, for example, if the charging should be not exceeding 15 hours. For example, if at a given point you want to do rapid charging using 15 hours, you wouldn't want to start sending more than 15 amps, much as the controller is also controlling the charge. So you put a fuse. So that if so at any one point, if the charge controller, if the charging was too high, that the current would be beyond what you need to use, then it was the fuse, not making the battery being charged in a funny way. And you can construct your own charge controller. I remember we made one time. And I will show you the photographs of our panel, making our panel. We had internet. If you go to the physics, not physics, if you go to Energy Made in Uganda Facebook page, Energy Made in Uganda, you may be able to see my photographs when I was making that panel. It was exciting. We soldered the first turbine wire on the solar cell and make an array, and then afterwards make your module. We used the car for sanding the arm headlamps of the car. And we made significant amount of voltage in the car. And we just said yes. That evening I was the most excited person. But we used the the motorcycle to shake the panel to make sure the other bubbles are removed. And the modulator and the presenter. So Mike has something to add?
Yeah, maybe on this battery, for example, the other which are this free maintenance and free maintenance, that means you don't what? Especially the sealed batteries, solar sealed battery, that's the free maintenance. That means you don't need to maintain it because there's nowhere how it is already sealed. There's no how you're going to the electrode. But now the other which needs to be maintained, that one which is using acid. Actually, they are even cheaper than these sealed ones on the market. Whereby that one you have to maintain it. So some people they can't afford the sealed one, and that's why they are going for that. Okay, so it depends on the cost, but the sealed one, the free maintenance sealed batteries are more efficient than what? The other which requires maintenance. So it's on the market actually, which is using that. With that one you have to monitor. You have to monitor when you are filling the watts, the electron actually this when they are filling the battery. There's somebody who's going to be doing the battery. You see how it is being done. When are they filling the electrolytes? And are you filling with distilled water or you are again filling with acid?
Okay, so I guess there are no more other questions. We've almost, now I'm putting on the cap of the moderator. I thank the presenter for making our evening shorter. And tomorrow is a special day. I hope the weather forecast will be better, where we will do task 3, where you have PV installation and commissioning, DC only. So you make your system. You will do the design of the wiring. You design the circuit diagram. We shall give you boards. We shall give you equipment in form of junction boxes. We shall give you a battery, an inverter. We need an inverter for DC only. And then you design once on your board, you design one set of the system for the DC, and then, but it's the same day, so you can still try to still make a diagram that will be able to house both the DC and the AC on the same board. So in the morning, you will do the DC only. After break, you continue. The time may seem to be enough, but if you make more arguments, if you make argument while you are designing, time can be here. We have experience with people who just argue, put this one here. No, we put it here. And by the evening, they have an evening feeling. And it is these systems we are going to make that we shall use on Friday for marketing. So you market your systems, and I will buy some if you convince me. I'm going to withdraw some good money. So if I don't buy your system, you know that the system wasn't good enough. So you have to market it, but it may be fake, but your marketing skills are good. So I may be woody to buy it. So on that note, I think we can call it a day. Thank you for having being attentive to the holiday. We see each other tomorrow at 8 o'clock again.